This is Al Wood with the Passaic County Center of the North Carolina Cooperative Extension Service. Of the three major grain crops grown in North Carolina, corn, soybeans, and wheat has the longest growing season, which is about 8 to 9 months. Depending on the part of the state you're in, planting could start in mid-October or later, and harvesting to commence late May to early June. Growing seasons can be highly variable. One season the wheat may experience warm temperatures and little rainfall. The next season may have very cold temperatures with excessive moisture. With the long growing season, using a formalistic approach which involves planting on the same date with the same variety, seeding rate, and fertility practices often results in less than optimal yield and lower economic returns. An approach that is better suited for the long growing season of a small grain such as wheat is adaptive management. In the publication, Adaptive Wheat Management, Increasing Wheat Yield by Adjusting for Weather Conditions, adaptive management is defined as a system that adapts management practices to current and predicted environmental conditions. See the link below to access this publication. It is based on an understanding of the key environmental factors and growth periods that influence wheat growth, yield components, and final yield. Using an adaptive management approach, a grower adjusts practices such as variety selection, seeding rate, planting date, amounts and timing of fertilizer applied, and the use of special practices such as growth regulators or pesticide to optimize yield based on the environmental conditions of a given growing season. During the time from emergence until jointing, when the growing point is located below the soil surface and the plant still has the ability to produce productive tillers, we need to be monitoring the development of the wheat crop. Some may ask, counting wheat tillers, why do them? An approximate relationship between tillers and yield is that for each tiller per square foot is about 1 bushel. So if we want a profitable yield, we want an acceptable number of tillers. A useful tool to monitor crop development and progress is tiller counts. Counting tillers also has us taking a close look at our wheat, which will provide the opportunity to evaluate other aspects of the crop, such as presence of insects, diseases, weeds, and nutritional needs that can be determined by tissue samples and other tools. To be able to properly conduct a tiller count, it is important to have some knowledge of the anatomy of a wheat plant. In this image is a seedling wheat plant. Starting with the seed, we know that the first part to emerge from the seed is the radicle or initial root, followed by the shoot, which consists of the first true leaf that is enveloped by the coleoptile. As the shoot pushes upward through the soil, the crown forms just below the soil surface from which roots grow. When the shoot reaches the soil surface, the first true leaf emerges from the coleoptile as seen here. In this image is a wheat plant with the parts labeled. Following the first true leaf, additional leaves develop. Once the main stem has 3 fully developed leaves, then the first tiller is formed. Tillers form in the axils of leaves on the nodes. The main stem could develop 7 to 8 leaves, and from a single seed you will normally have 4 to 5 tillers, although there could be more than that with a given wheat plant. In addition to plant anatomy, it is important to understand plant development as delineated by growth stages. There are a number of different growth stage scales, but the one used in this video will be Figs. A few notes on growth staging plants. First, select plants that represent at least 50% of the field. Then, dig plants if possible so you can assess the entire plant. Next, start at the base of plant and work your way upward. Use a knife to split the stems and sheaths, and look and feel for nodes. Seeds are planted at a depth of about 1 to 1.5 inches. Seedling emergence, depending on the planting date, planting depth, and weather and soil moisture, could take from 10 days to 4 weeks, which could occur on a late planting date followed by cold temperatures, although under optimum conditions, normally about 2 weeks. This image shows a wheat seedling at Figs 1. A newly emerged seedling will consist of a single leaf. The original stem will continue to put on leaves and could have as many as 7 to 8 leaves. Week 1 is an important time to check wheat plants for uniform emergence and to determine if it is necessary to apply herbicides to control winter annual grasses or other weeds. Once the plant has developed its first tiller, which is the first stem after the main stem, the plant is at week 2. This is when we consider the plant to be tillering. The plant is in this image is at week 2. It is hard to distinguish a wheat plant from week 2 and week 3. A plant at week 3 is ready for dormancy, with the most productive tillers already present. Up until this point, especially once a plant has a lot of leaves and tillers, it lays somewhat flat on the ground. Wheat goes through vernalization, which could be from 3 to 6 weeks, depending on the chilling requirements of the variety, before breaking dormancy in late winter or early spring. Although you may have done a stand evaluation shortly after emergence, it is from week 3 through week 5 that tiller counts are most useful. During these stages of plant growth, tiller numbers can be enhanced with split applications of nitrogen if tiller numbers are not optimal. After many of the tillers have been formed, wheat plants enter the greening up phase and begin erect growth. This stage is known as week 4 and is closely followed by week 5. The image shown here is of a plant at week 5. Although these stages are difficult to distinguish from each other in the field, they are important and distinct stages in the plant's development. Week 5 will not occur prior to vernalization or chilling, which occurs during the winter. After vernalization, wheat plants begin to differentiate. At this point, wheat head size, the number of spikelets per spike, is determined. Any additional tillers that form after week 5 will not contribute much to yield. The growing point of the main stem stays below the soil surface all the way until the end of week 5. It is at week 6 that the growing point starts to move upward. In this image, we can locate the first node, which is just above the ground. These images are for week 6. In this image is the first node and the immature seed head. Week growth stage 6 is commonly referred to as jointing. To determine if a plant is at jointing, dig up the plant, remove the tillers, and examine the main stem. The first node often feels like a swollen bump on the base of the shoot. Using a knife, split the stem in half and observe the position of the developing head and nodes. If a node is visible, the plant is at week 6. The head will be visible at this point, and the spike will contain all potential spikelets and florets at week 6. It is during weeks 3 through 5 that we can do the most good with tiller counts. Although spring tillers are not as productive as fall tillers, the timely split application of nitrogen can boost yields, especially fields with marginally low tiller numbers. For North Carolina, the best time to do tiller counts would be starting in late December until early March. As mentioned earlier, doing tiller counts allows us to also observe other aspects of the crop, such as presence of weeds as seen here. Hessian fly pupa, as seen in this image at the tip of the ink pen on the tiller, as well as various diseases, have been identified in fields in northeast North Carolina in January and February. Also, if the wheat does not have the color it should, it is a good time to take tissue and soil samples. To do tiller counts, we need a measuring tape, shovel, or hand trowel. For broadcast wheat, a square made of lightweight metal or wood with each side 1 foot in length works good. Also, warm clothes are needed many times since it is very cold, and I've even had to brush back snow to do tiller counts. Here we are digging and taking a sample for counting tillers. When taking tiller counts, we want to be evaluating what is representative of the field, and we may take 2 or 3 of these in the field. Here is a table that shows the sample size in linear row inches needed for various row widths to get a square foot sample. If you use the square for broadcast wheat, you just place it in areas that are represented in the field to get the tillers per square foot. When counting tillers, count those that have at least 3 fully expanded leaves as seen here. As I mentioned previously, a tiller is not able to sustain or feed itself until it has 3 functional leaves. It does not mean that they will not eventually be productive tillers, but you want to know what the number of productive tillers are at the time you do the count. Especially when counting tillers in January, keeping up with the countable tillers as well as the tillers that are not countable will let you know what your potential number of tillers are. In January, you have more time for tillers with less than 3 leaves to become productive compared to those in early March. One other thing that I have noticed is that tiller size can vary a lot, so you can not just look at the tiller size to determine if it's countable. You have to do a close examination of the tiller to make certain that it has at least 3 fully expanded leaves. I have seen 2 tillers from different fields as well as different planting dates with 3 leaves, and one could be twice as tall as the other. Just remember to do a close examination of tillers. The following images are from fields that tiller counts were conducted in 2018. For each field, there is a wide view and a close-up view to give you a feel for a range of tiller counts you may encounter. Even with the wide view seen here, the plant stand looks thin. With the close-up view seen here, 13 tillers per square foot looks very thin. This field has a much higher tiller count than the previous field, at 66 tillers per square foot, and looks good even with the wide view. With the close-up view seen here, the 66 tillers per square foot looks good. This field has 99 tillers per square foot and looks very good. With the close-up view seen here, the 99 tillers per square foot looks thick. The challenge will be to keep the numbers of tillers up by properly managing this field. Once we have completed our tiller counts for a field, then we can use this information to make recommendations. If we are doing stand evaluation after emergence to late December, and we are certain that all the wheat has emerged, and we have tiller counts like the one with 13 per square foot shown earlier, especially if it is not uniform, then that field may not be suitable to be carried to harvest. You may want to contact your local extension agent to get guidance from them, and if you have crop insurance, your agent to let them know your situation. If we are in late December to mid-February and we do not have at least 50 tillers per square foot, but the field appears to have the opportunity to provide profitable yields, then apply 30 pounds of nitrogen per acre. If I had 50 tillers per square foot and the wheat is not green as it should be, I would still put 30 pounds of nitrogen per acre. To make certain that it is not something else other than nitrogen, a tissue sample should be taken. From mid-February to early March, if we are at 50 tillers or less per square foot and have a good enough tiller count to keep to harvest, then apply 1/2 of the remaining nitrogen be applied, with the other half to be applied prior to joining, or feed 6. During this same time, mid-February to early March, if we have 60 to 70 tillers, then apply 30 pounds of nitrogen per acre and apply the remaining before joining. If you are only 2 to 3 weeks before joining, feed 6, it may be that you would want to go ahead and apply the remaining nitrogen. If you are having rainy periods that are keeping you out of the field, to apply the top dress nitrogen in a timely manner. A thing to remember during all of these time periods, we want to consider not only the tiller numbers, but also the plant nutrition. If the appearance of the plant indicates that nutrition is not adequate, then taking tissue samples and taking appropriate action may be necessary. The point is that we want to keep the wheat plant progressing in a manner to realize its potential yield. So far in this video, we have been talking about nitrogen applications in terms of pounds of nitrogen per acre, or percentage of total to be applied. An important point is how much total nitrogen to apply to your crop. For fields that have a yield potential of less than 100 bushels per acre, that has enough tillers to carry the field to harvest, I would use no less than a total of 120 pounds of nitrogen per acre. Based on results of years of entries from the North Carolina Wheat Yield Contest, it has been shown that total nitrogen applied by wheat growers that obtained 100 plus bushels per acre of wheat was about 140 to 150 pounds per acre. I have seen that to be the case with some of my growers with high yields. They are applying these higher rates of total nitrogen. Although this could vary according to a grower's situation, 30 to 40 pounds of nitrogen could be a part of their pre-plant fertilizer. The remainder would be put on later in the growing season, with the majority of that being applied at top dressing, which is prior to Feed 6. One of the concerns about nitrogen application late in the growing season is the burning of foliage. Speckling can even occur with certain chemicals that are applied along with the nitrogen, like in January or February. But once wheat gets into Feeds 5 and later, the leaves are much more sensitive to nitrogen burn and other plant nutrients containing salts. The big concern when running over wheat once it is at Feed 6 is that the growing point is above the soil surface. Once the stems get taller, we have behind the growing point a hollow stem that can be crushed as well. Running over the growing point and stems can kill or damage the wheat such that it is not as productive. Some growers have tram lines, gaps where there are no plants for the tractor to travel on. Other growers, especially those that make several passes across the field during the growing season, establish tracks in the field that are used each time a tractor or sprayer goes in the field. I hope that this video provides you with the information necessary to conduct a correct tiller count in the wheat. If you have questions, please contact your local extension center. This is Al Wood, Field Crops Agent with the Powhatan County Center of the North Carolina Cooperative Extension Service.